Hi guys, so the last video I'm going to do is on circle theorems and proof. Each of these topics, circle theorems and proof, are quite massive really, and they need loads and loads of lessons. But I'm just gonna quickly go through each one. So each circle theorem, and then we're going to try to apply proof, so to prove a circle theorem together, and then I'm going to show you how to do an exam question on circle theorems and proof. So hopefully you guys have already started thinking in your heads about what all the different parts of circles are. Hopefully you know most of them, so you know what circumference is, you know what center is, you know what radius, what diameter is, and stuff like that. We might learn some new ones throughout this video, and I'm going to explain you exactly what they are. So the first theorem says that the perpendicular bisector, and this is the perpendicular bisector, this line here, so which is basically a line that is perpendicular, so it forms a 90-degree angle with your chord, and it cuts the chord in half. So that's the perpendicular bisector of any chord passes through the center of the circle. A chord is this line here. If I can just grab something else, I'll go for blue. Okay, so this is the chord. Obviously it's not only one chord, there can be loads and loads of chords. For example, this would be another chord, this would be another chord, and so on and so forth. But any line that you draw like this, so that it's the perpendicular bisector of the chord, is going to go through the center of the circle. Another thing that you might find useful to know is that chords split the circle into two segments. So if I try to clear this up, okay, so for example, this chord here that they gave me in the question splits the circle into a major segment, which is this. That's a major segment. Major segment. And the little one here, which I might do in purple, why not? So this little one here, this bit here of the area of the circle, is a minor segment. Okay, so this word segment is going to come in handy, we're going to see in the next few theorems. So let me go back to red. Okay, so let's look at the second one. It's pretty important. It comes up in loads and loads of questions, actually, in exam questions. And it's actually a special case of another theorem. So number 2 is a special case of number 5. I'm going to explain that to you in a second. So the angle in a semicircle, so do you see this angle here formed by the diameter? So the angle in a semicircle is always 90 degrees, and that always comes in handy. The reason why I'm saying that this number 2 is a special case of number 5 is because if we look at theorem number 5, it says the angle at the center, so POQ, is twice the angle at the circumference. So POQ is twice the size of PRQ. Okay, so for example, if we said that this is, I don't know, let's say 35 degrees, then this one would be double because it's the angle at the center, so that would be 70 degrees. So if you guys have a look at this one, at number 2, the angle in a semicircle is always 90 degrees. Do you know that this is 90 degrees here because it's formed by the diameter and it's in a semicircle? So if you look here, you've got the diameter, which is a straight line, we know angles in a straight line are 180 degrees, and there you go. So 90 is half of 180, so it's kind of the same thing. So yeah, that was that. Next one, number 3 says the radius, and that's the radius, and the tangent, which is a line that touches the circle at the circumference, always meet at a 90-degree angle. That's another handy one, very useful. Okay, so let's see. The next one says angles in the same segment are equal. So if we remember from here when we were talking about segments, from number 1 when we were talking about segments, and my example is that ABC, so angle ABC is equal to angle ADC. Okay, because you guys see they're in this major segment here, so they're equal. Okay, it kind of looks like a bow, the shape. Yes, so it kind of looks like a bow. That's how I remember this one. So these two angles are equal. Okay, we talked about number 5. This again is a question that is very popular actually in at GCSE. So the angle at the center is twice the angle at the circumference. Yeah, just memorize it the way it is. So memorize the verbiage, because you quite often are asked to give reasons for your answers or to do proof. So we need that. Okay. Theorem number 6 says that opposite angles of a cyclic quadrilateral add up to 180 degrees. So a cyclic quadrilateral is basically a quadrilateral that has all 4 vertices, so all 4 corners on the circumference of the circle. So here's an example on the slide. And what that means is basically if you add these two angles, because they're opposite, so if you add up x and y, you're going to get 180. And if you add up a and b, you're also going to get 180. So that was that. Okay, number 7 says the lengths of 2 tangents from a point are equal. So I think we're going to see an example of this one in our exam question actually. So what this basically means, you've got 2 tangents here, TR and SR. So from this point to the point outside the circle is the same as from this point to here. So basically you can say that these lines are equal. So that's going to help us. You can form loads of triangles and quadrilaterals and stuff like that, because you know the properties of those. We're going to see that applied in the exam question. Okay. The last one is a bit of a weird one, and I think people don't usually kind of grasp this one very well. I have to say, usually what I've seen exam wise, you can get away without sort of knowing how to apply this one, but I wouldn't recommend it, because well, with you guys exams, we never know what they're gonna ask. So yeah, let's look at it. So the angle between a tangent and a chord, so this angle here, that one there, is equal to the angle in the alternate segment. So you see, if here you've got the minor segment, the alternate segment is the major segment here. So we've got this angle that is the same. Yes. So it's also known as the alternate segment theorem, and the only nice thing about it is that when you come to do your explanation or to give reasons for your answers, the examiners do accept you guys just saying, oh, alternate segment theorem, so you don't actually have to go ahead and explain this angle and with the other angle and alternate segments and blah blah blah. I can just say alternate segment theorem and just justify like that. Right, so let's try to prove theorem theorem number 6, that opposite angles of a cyclic quadrilateral add up to 180 degrees. So that should be your next thing. It's already on your handouts. So just sort of like have a look and try to follow what I'm saying. So we saw before that opposite angles in a cyclic quadrilateral add up to 180 degrees, and we want to prove that. So if you have a circle and you've got a cyclic quadrilateral, so any quadrilateral with all 4 vertices on the circumference of the circle, that's a cyclic quadrilateral. You can just choose 2 angles. So in my case it's A and B because they're opposite. Okay, so we label the angles and we want to prove that A plus B is equal to 180 because that's what the theorem is saying. So the next step we have to do is, maybe I should have had another circle here, but what we want to do is draw these radii here. Okay, here you go. So you just draw these lines, so to your original. So basically in this one all I did is I drew that one and I drew the other one. Okay, so this is where we start using another theorem that says that the angle at the center is twice the angle at the circumference. So I can start labeling basically. So if I know that this angle is B, the angle, so that's the angle at the circumference, and I know the angle at center is going to be 2B, and the same goes for A. So if this bit here is A, then the angle at the center is going to be equal to 2A, which is basically what's done much nicer there in that one. Okay, so here we're basically at the center of the circle, so we are working out of 360 degrees. That's the amount of angles at a point. So I know that I'm going to write here 2A plus 2B equals to 360 degrees, okay, because they're angles at a point. So I know that 2A plus 2B equals to 360 degrees. Now if I simplify this, so if I divide everything by 2, which we know we're allowed to do as long as I do the same thing to both sides, so 2 divided by 2 is 1, that's an A. Copy my plus, 2 divided by 2 again, that's a 1, so I just bring my B down. 360 divided by 2 is 180, and there you have it. We proved that A plus B is equal to 180. Okay, so this basically describes what we did. We drew the radii, so here we labeled our angles 2A and 2B, so we used the fact that angles at a point add up to 360. We know that 2A plus 2B is 360 because they're angles at a point. And there you go, A plus B equals to 180, so we proved the theorem. Okay, so let's try to have a look at the exam question. I'd say probably let's try to look at it together. You guys can flick back and forth between the sheet with the theorems and this page, hopefully. Please annotate on the question. So we've got A, B, and C. So A, B, and C. They're points on the circumference of the circle center O. TA and TB are tangents to the circle, so they touch the circle. I know that CA, so this chord CA is equal to chord CB. I also know that angle ATB is equal to 2x, which is already labeled. And we want to prove that angle ACB is equal to 90 minus x degrees. So let's kind of have a look. The first thing I would want to look at is, if you guys remember, the tangents from a point to the circumference meet the radius at a 90-degree angle. At the moment, I don't have a radius, but as always with these questions, you have to kind of like make your own. So create your own. So if you guys draw a radius in, so AO, and if you draw another radius in on the other side, so OB, and now we know that angle TAO is equal to 90 degrees. So we are going to say angle TAO is equal to angle TBO is equal to 90 degrees. And in brackets, we have to say that tangent meets radius at 90 degrees. Meets radius at 90 degrees. Okay, or to form a right angle, whatever you want to call it. But that's the idea. Okay, so we've got that 90-degree angle there. We've got another 90-degree angle here. So now we can work out angle AOB in terms of x, so in algebra. So I know that angle AOB is y. Oh, why does it keep doing that? Sorry. Okay, so we know that angle AOB is equal to 360 degrees if we're working in this quadrilateral. So in AOBT, it's a quadrilateral and it has 4 sides. So we know angles in a quadrilateral add up to 360 degrees. So if I want to work out this angle, I basically have to do 360 minus that one, minus that one, minus that one. So I'm going to do that. So 360 minus 90, and minus our given angle, which is 2x. So if I do 360 minus 90 minus 90, that's 360 minus 180, that's 180 degrees. So that's 180 degrees minus 2x, right? And to justify that, we have to say that angles in a quadrilateral add up to 360 degrees. And it's going to be long, so angles in a quadrilateral, my handwriting, equal, or you guys should say add up to, and I shouldn't be lazy, add up to 360 degrees. Okay, and yes, so let's annotate that on our drawing. So that's 180 minus 2x. So we're nearly there, believe it or not. It looks like I'm peeking at the answers, which I'm not. Okay, so now for our last step, we are looking in this shape. I don't even know what to call it. Might want to call it a V. I prefer to call it an enterprise badge, but you guys are too young for that. Anyways, so in this shape here, do it with green, like that. So in this shape here, I've got the center, I've got point on the circumference, and I know that the angle at the center is double the angle at the circumference. So I can now tell the examiner that angle ACB, this is so annoying, so angle ACB equals to, okay, so equals to a half of angle AOB. So angle AOB divided by 2, right? Because it should be half. Okay, this PowerPoint's hard enough. Okay, we're back. Okay, so I can now divide my angle AOB. So angle AOB is 180. Sorry guys. Okay, so 180 minus 2x. God, what is going on? Come on, video, you can do it. Okay, so 180 minus 2x, we said we're going to halve it. Let's do it quick before it moves forward again. Okay, so 180 divided by 2 is 90. 2x divided by 2 is x. And there you go. We proved it. Let me go back hopefully for one final time. You guys record the reason being that angle at the center is twice the angle at the circumference. So that has to be written in your paper. Okay, so that was that. Guys, that's all the topics that we haven't done. Finished. As always, if you're still unsure after my explanation, watch Maths Watch. I'm going to try to attach the clips at some point, hopefully I'll show my homework. Good luck with revision and good luck with your mocks. Bye!